Yes, so today's topic is we're back on the origins of the standards for AGL, and this is part 2. As you recall, last time Tony Smith gave us a very interesting insight into the development of the standards for approach and runway lighting, and of course the PAPI, of which he was responsible for inventing. So and there was so much in the topic, we initially thought about doing this as a one webinar subject, and I'm not sure that we couldn't have spilt into a whole series, but we're trying to go for 2. We've had a very interesting discussions about it already today. Part 2 is taxiway lighting and signage. So without any further ado, just to mention, if you do have any questions, I see a Q&A, we have one already, but if you can put them on the Q&A box on your screen, and then we'll take them for about 20 minutes at the end of today's webinar. And if we don't get around to your question, they will all be answered, and answers will be posted on our TMS Training Solutions webinar page. So please put your questions in. We really value your contribution to this discussion. It is at the end of the day for your benefit. So we're here to answer your questions and help you make your airports safer, more compliant, and of course more efficient. So on the panel today will be Tony, of course, Seward Ford, representing the whole of the North America, and Keith Costel, our leading lead trainer and renowned expert on all things airfield lighting and airports generally, really. So without any further ado, I'll hand over to you, Tony. If you could enlighten us on taxiway lighting and signage origins and how we got to what we have today. Thank you.
Right. Thank you very much, Robert. It's good to be talking to you again. The second part of the series of 2 on standards. And I just want to say at the beginning what I said last time. In the time available, one can't go into all the minutiae of these topics. I've tried to focus just on the core information. There are things in the annex which there really isn't time to talk about today, but I hope to give you a good input into the core issues around signs and taxiway lighting. The second thing to say, of course, is I sit here in the United Kingdom and was part of the research development program for many years, and predecessors before, all having a big input into ICAO visual aids panel, but very aware that there are other states who had programs as well, which ran in parallel, and we learned from each other. I mean, the fact that Seward's here today, the FAA had a very large input into the discussions we had. So whilst I talk about things from a UK point of view, in a way, I think it does reflect a wider consensus of what the visual aids panel did. So let's go straight on to signs then. First of all, before talking about where the detailed specifications come from, I thought it was important just to put a marker down. There's some very basic things about signs. First of all, the basic requirement of any sign, and this is true not only of signs but other visual aids that give pilots cues, the signs have to be conspicuous, legible, credible, and comprehensible. Or putting it another way, they need to be conspicuous, that they stand out from the background, easy to find when you're searching for them. Legible. Sign isn't much good if you can't read the information on it. It must be easy to read. It has to be credible. In other words, the information, once the pilot has seen it, he must believe, or she must believe, what it's telling her. It makes sense. And then comprehensible. The information then must be easily digestible to lead to a decision, for example, as to whether to turn to the left or to the right at the next intersection. So those 4 things have to be there in a sign. the sign also, it should be provided so that it enhances safety. That's what it's there for. It's part of the safety system, and it works by augmenting the pilot's situational awareness. The pilot knows where he or she is on the airport at all times. They know where they are on the road, as it were, and they have other information, the verbal ATC instructions as to where they should taxi and when, and the reference to airport maps, probably today in the cockpit on the display, but paper charts as well, which give a lot of information about the layout of the airport, for example. And all that together with the signs, you know where you are on the map, as it were. And secondly, the important thing about the sign is that they form the basis of the ring of red, the visual cueing system that protects active runways from incursions. And I mention that because at the time we were doing the work in the visual aids panel that resulted in the standards we have today, there was a great concern about runway incursions, which were continuing to increase in number. And interestingly enough, a study done by the FAA showed that most of the incursions weren't in bad weather or even at night. Most of them were on clear days. So visual cueing is an important way of ensuring, and I have a sort of recollection that I first used the phrase ring of red, certainly in our discussions. I got a map and I just drew a red ring round the runway and said, all the ways you can get onto this runway must have something red to make you aware that you're getting onto a runway and that you have to get a clearance or whatever to proceed onto that active runway. So the ring of red, the signs are an integral part, the mandatory signs we'll talk about in a minute, an integral part of safety, of trying to, as well as we can, prevent runway incursions. So if we go on to the next sign then, please, next slide. So how are the basic requirements for signs met? Along the top, I've got parameters, the 5 things that determine whether a sign is good for its use. As I've already said, conspicuous, legible, credible, comprehensible. And I've added in the 5th one, of course, very important, the usable range. Can you see the sign from far enough away to make good use of it? And the parameters in the other dimension that decide the performance of the sign to meet these requirements are the luminance, the brightness of the sign, the color or colors on the sign, the size of the sign, and the layout, the font layout, the letters and other symbols there might be on the signage. All of those in the various ways contribute to a sign being fit for purpose. For example, as far as being conspicuous is concerned, the sign that is placed for use must have sufficient luminance. It must be bright enough to make it conspicuous against the background. It must have colors which are readily seen. You could choose, for example, if you think about it, if we'd chosen green for one of the sign colors, that might be quite a good camouflage color in some situations. The color you choose for conspicuity is important. The size is important, and I'm going to say more about that later, but there has to be an adequate size to be conspicuous. You don't want something that's no more than a sort of point source of information. You want something that's got dimension and you can see it clearly. When you go to legibility, all 4 of those are important. For a sign to be legible, it has to be sufficiently bright. The colors have to be appropriate, and pairs of colors, the color contrast between different colors, that's important. The size of the lettering very much determines the legibility. If your letters aren't big enough, then you can't see them from the range that they need to be seen from. And the font layout is part of that. The layout of the font, what font you choose it can be very important in this. And then the credibility is particularly enhanced and focused in the right colour being seen for what information you're trying to display, and also the font layout, which I'm going to say more about later on, but having the right layout of the font is very important. And then comprehensible, similarly, the colour. So example, you know that this is an information sign or it's a mandatory sign by the colour, and the font layout is also comprehensible. It makes sense, and again, I should be saying more. And the range, all four of those elements contribute to the usable range of any sign that is provided. So if we go on from that, and go on to the next slide, and we'll start looking at the history of SARPs, the standards and recommended practices. If anyone isn't familiar with the acronym SARPs, that's what it is. It's a standards and the recommended practice. In other words, Annex 14, as far as we're concerned. So looking back in the early 1980s, I looked at my 1983 edition of Annex 14 and the accompanying ADM. If you look at the annex then, it was a bit sparse, to say the least, about the information. There were some drawings of ways you could make a box and illuminate it inside, and there were some signs suggested that could be used, but it was far from comprehensive. Talking to pilots, it was clear that pilots going from one state to another in particular would find differences in sign terminologies. They would find different sign colours. I mentioned green a few moments ago. There was one state that got quite a plethora of green and blue signs, in addition to the colours that we finally chose, if you like, yellow and red. So quite confusing, and very different illumination standards, and location of signs was not well spelt out what was necessary to have the right level of safety and implementation. And all of this put together meant that the pilot did not get from the signage that was specified in those days the situational awareness that he needed or she needed. So situational awareness, knowing where the aeroplane was, it was where it should be. There were inadequate levels of that at times. And talking to some of my former test pilots who had then gone to fly on civil airlines, they said the most adrenaline causing part of the whole arrival at an airport was the taxi in, when you could get lost and inadvertently get on an active runway. That was when their adrenaline was going to the highest level, they thought, of the whole of the procedures. An airport, particularly, they didn't know very, very well. And so in the late 1980s, the Visual Age Panel was given a task, and it identified the need to enhance this international taxiway signage system to improve situational awareness and thereby enhance levels of safety to prevent taxiway accidents, and also, of course, to enhance efficiency so that pilots could taxi securely, knowing they were going to the right place in the right way. So in the 1980s, the Visual Age Panel began to look at what was already out there, looking at national practices, looking at various signage systems, and identifying, as they did that, where deficiencies were in what was then in Annex 14. So if we go on now to the next slide, please. So what did we do in the VAP? One of the things we did, we looked at other signage systems where high levels of standardization already existed. And for example, one of the most helpful ones was to look at road signs. There was a lot of quite detailed information there that could be fed across to help us define the signs that we should use. it has its limitations, of course, because one of the things on an airport, you can't have a very tall sign. Some of the signs on the road are quite large, not only laterally but also vertically, and they have pictograms on them. For example, in the UK, certainly where we have roundabouts, you often get a big sign with a big circle with arrows on it, so you can see, well, I'm on this road, and if I want to go to the first turn, will take me to the left, and the second one will straight on, and so on. You can't have signs of very large vertical dimensions, so we couldn't just lift straight out the road sign information. But it was very useful, luminance levels and so on, all very helpful in beginning to put together a signage system. We talked quite a lot about, well, what are the operational requirements? I've already mentioned some of those previously in this talk this afternoon. We identified the things that the signage system should provide and meet. So by the early 1990s, the visual aids panel had got into a experimental phase, as it were, having garnered all this background information. And we went into doing laboratory experiments. And one of those in particular, and I'm going to talk a bit more about in a minute, was the layout of the sign with the restrictions that we couldn't have a very tall sign. It has to be a sort of linear array to provide the information. How were we to lay that signage out so it was credible and comprehensible? We also looked at if we were going to provide and ask for signs, what means were there of providing it? We knew of the internally lit sign, the trans-illuminated sign. They are on the market, had been for quite a few years, but other options were around in the 1990s. Fiber optics were quite a common solution being used in all sorts of, really before LEDs themselves, although they were coming along, lit panels of various sorts of other technologies were being proposed, and we looked and assessed those. We looked at examples of them from manufacturers, and out of all that we identified a comprehensive signage system. And this included not only the signs themselves, but where they should be located in relation to, example, the distance from the taxiway, and on the taxiway, where they should be in relation to a junction. That sort of more detailed information. So the pilots, when they were looking for information, would know where to look in relation to where they were in the taxiway system. The signs should appear in the same sort of places. And in fact, if you look at Annex 14, a lot of the detail, which I don't have time to go into much today, is where you put the signs. Talking amongst ourselves earlier today, it's important to say the signs are shown as being, as you like, the actual sign sighted at a right angle to the taxiway itself. It may be advantageous sometimes to turn the signs in towards the taxiway centre line to avoid the worst of jet blast, for example. But bearing in mind, if the signage is on both sides of a taxiway, if you're approaching it from one side rather than the other, you'll see one side before the other. You'll see the information there. As you get closer, you'll see both sides. But those sort of things probably best dealt with at a national or even a case-by-case information as to where you put it in the one sense of where you point it, but where it should be in relation to the actual runway or stop bar, or that's pretty comprehensively dealt with. So if we go on to the next one, from that sort of history here, I mentioned the human factors side of it. Important, the layout of the sign. We had quite a lot of discussion about this. We had a lot of pressure from inputs from manufacturers of this side of sign who wanted to put the information as to which sign you were on at the end of the box rather than anywhere else, because it's easier to make that way. It'd be $10 cheaper. So whatever it be, that there were quite a lot of siren voices like that, but we tried to be very objective and look at the possible different layouts, and there were several alternatives, but we coalesced on this type of solution, where in fact what we were going to specify was that first of all, the taxiway you're currently on should be shown as a yellow letter on a black background. That says this is where you are now. You're on and on that sign that you see there, you're on taxiway B. Now then, there may be turnings that you may need to make now as you come to the junction, to the left or to the right. So the next decision was everything that was related to turns to the left should be to the left of your location sign, your black sign. Everything that was to the right, any turns to the right, should be to the right of the location sign. And then furthermore, what order should you put them in if in a complicated taxiway? Well, the one that has the least turn required to join that taxiway is put nearest to the identification sign. The next largest turn is next to that, and then the one that is the most comprehensive turn is put the furthest away. So there's a sort of logical flow. You look along the sign and you see, yes, for example, I'm going to turn right here onto Taxiway Echo. You can see that there are two other. You've got to take the third exit then, if you like. It's very helpful information. So to validate this, I set up an experiment where I got a cohort of people who are aviation savvy, people pulled off the street, people who are aviation savvy, and I gave them a test card, an examination card, and what they were given on the left-hand side of the page was a whole series of signs, like the illustration I've shown here, quite a complicated one. Some were less complicated than this, but there were 10 of them. And on the right-hand side, alongside each one, was a blank space. They were given a pen and they were asked to draw a plan view of what that, from the sign, what that junction layout was. Now, they were given 10 seconds to do each exercise, to do each sign, because we determined, and I'll speak a bit more about this in a few moments, that 10 seconds was the maximum time you could assume the pilot would be able to read this information. So in the 10 seconds, they've got to find it, they've got to read it, got to make a decision, probably cross-check with their map or whatever. They've got 10 seconds to make this decision. Then they're past the sign. If they haven't made an executive decision by then, it's too late. So 10 seconds to answer each question. They were given 10 of these, so that was 100 seconds. So just over a minute and a half, they were sat down with that thing and they're asked to do the drawing, typically, as you see on the right. The result of that was that of all the people that took part, when we showed them this type of sign layout with the information as I described it, with the designation where you are in the middle and so on, signs that were shown like that, the people taking part got the right answers 100% of the time, and often finished the task within the 100 seconds. There was ample time, they weren't pushed for time, and they could get the right answer without fail. Other suggested layouts were also trialed, and in there we found significant numbers of misinterpretations of the sign, the wrong answer being given on the right hand side, and also quite a number of candidates didn't finish the task in the 100 seconds they had allocated. That gave us all in the visualization panel, I think, a fairly firm view that this type of layout was the one that we should specify, and that's what you have today in Annex 14. So if we go on to the next slide, please. So I've already mentioned operational requirements. Here is a view of, in summary, what we determined was a specification requirement that coming out of the operational requirements. As I already said, the sign should be fully usable for a period of 10 seconds. The viewing range should be sufficient so that you could see it and read it for the full 10 seconds. The sign needed to be such that, and that as a distance, we said, for operational requirements purposes of 500 feet, 150 meters. You should be able to read the sign from that distance. Now I'm talking about good visibility conditions. Why the 500 feet, 150 meters? That figure was based on data that was gathered actually at Heathrow as a separate study of taxi speeds at airports. And what that showed was that in clear conditions, taxi speeds are well represented by a figure of 30 knots. Of course, occasionally it will be a bit faster than that, sometimes a bit slower, but taxi speeds of 30 knots was a good design speed to work with. And that gives you a distance of 500 feet for 10 seconds. There's a matter of sign luminance. We're aware that what we chose had to be practicable within the technology that was available in those days, 20 years ago now, but at the same time sufficient for viewing range requirements. And bearing in mind, if you're going to have effectively a common light source in which you put panels, then the transmittance of various coloured panels, you'd get different luminance values. And so they're not all the same value. This is where practicality impinges. And so you might at first instance say, well, they should all be surely the same sign luminance. In an ideal world, yes. Today, when we've got signage, that you can see, you see it in sports stadia, you see it on the roads now, signs. Nobody on big billboards these days, as far as I can see, any longer puts up a big paper notice board with paste and the man doing that. They've got these lit signs now that they can address and put different things on. That technology wasn't available then. If we were reviewing this today, I think we could standardize the luminance level so they were the same for all the colors. The location I've already mentioned to be standardized so that, for example, a hold where there's a stop bar and markings on the ground, where the sign is put in relation to that is standardized, and you'll find that in Annex 14. Going back to sign luminances again, they're standardized, as I've already indicated. Those are minima, and if someone makes something that's slightly different to that, but a little higher, particularly in perhaps the reds, for example, if you can achieve that, that is surely a good thing. But the sign luminances are important. And as we're basically in a seminar that very much has its roots in maintenance standards, it's very important that sign luminance, the even illumination across the whole screen, and the level of the luminance needs to be provided the initial installation, and it needs to be maintained. It needs to be checked in field. Necessarily, the sign needs to be cleaned and so on. There needs to be maintenance on signs. It isn't, again, another fit and forget that they need maintenance to maintain that sign luminance. The font layout, I've already again talked about this, about the present taxiway being central and so on. So I won't spend a lot of time on that next point, because the layout of the sign is there in the example I gave. And of course, this does mean to say you can have a long linear sign that doesn't produce an obstacle to wings or even engines of the aircraft when they're taxiing. It's low to the ground. The font height, very important. How big do the letters need to be? Looked into the science of this, and basically very good eyesight, you can see a letter, provided it is the right contrast, the colors and so on. You can see very well a letter on a sign which is 1/600th of the distance you are away from the sign. In other words, if you're 600 feet away from the sign, the letter needs to be 1 foot high. Mind you, that is really laboratory best conditions situation. So we chose 1 in 400 as the guideline as to how high, how tall the font letters should be. It's a useful thing wherever you are. It's a good number towards carrying your head when you're looking to put any information up to be read. The size of the letters should be at least 1/400th of the maximum viewing distance that you're going to see them from. And then, of course, the color convention. We were quite clear. Mandatory signs had to be red and white. Red is the obvious sign color for a mandatory instruction information. The information signs can be yellow. That's fairly standard in other places. It's information, and so yellow with black lettering, or black with yellow lettering. Just 2 colors in the whole system. Having run through that, I've got a note here saying that this assumes good visibility, particularly at night. This is, if you like, when you expect aircraft to be moving at the highest speeds and in good visibility. So then the question comes, well, what about when the visibility is less than this? Is the signage system still adequate? Well, the point to remember is that in low visibility, the viewing distance is almost inevitably going to be reduced. So in a sense, your font height is over-provided for, but you've got to provide for the clear day. If you're only ever going to operate in less than 400 meter conditions, you needn't have such a big font, and the signs shouldn't be readable. Well, they won't be readable from distances of 500 feet away anyway. So it's sort of self-healing. As the speeds are reduced, it's still adequate for the task, and the viewing times that you need, the 10 seconds, will still be met. You say, how do you be sure of that? Well, the pilots will do that for you. If they need 10 seconds, they'll taxi at a speed commensurate with the fact that that then gives them sufficient time to read the signs. So it may well be they're not 500 feet away when they first see the sign, but they'll have adjusted their speed, so they still got 10 seconds when they first glimpse the sign to read it. So that does mean, of course, in the very lowest visibility, and it happens, the taxi speed might well be below 10 knots. But that's so it is a sort of fail safe sort of situation, choosing the highest demanding case as the operational requirements case. So let's go on to the next slide. So I've just put up from Annex 14 2 or 3 examples. I'm sure you've seen them. I'm just putting them through illustration. There you are, red signs with white lettering. They're only examples. There are there'll be other situations. You use the same methodology, the same fonts, same colors to put whatever information up you need to do. So there we are. That's an example of mandatory signs. If we look at the informational signs next, I think they'll come up in a minute. There we are, a sample of informational signs. Quite a lot of good information there. For example, location, runway vacated sign, one on the left-hand side of the taxiway, one on the right-hand side. There will be other informational signs you might want to put that have other things on them, particular to your airport, but use the same methodology in terms of size of letters and colours. That's what essentially that example is saying to you. So let's go to the final one of the sign things. There we are. I've talked a bit about this. The Annex 40 helpfully shows you where you put the various signs in various situations. So let's move on from that, having spent our time so far on signage. Going to taxiways, this won't take quite as long, I assure you. We're not going to overrun too much of this, but let's look at the taxiway. It's instructed to look at the early standards and the SARPs, where it all comes from. So certainly what I know is that one of the first applications of taxiway centerline lighting in a significant way, rather than the blue edge lighting, was implemented when London Heathrow was being developed in the late 1940s. Ted Calvert of Calvert Approach Lighting and Vases was on the planning committee and had a strong influence on what was put into Heathrow. And he proposed that to enhance safety and the facility with which pilots could taxi around on what was going to become a complex airport was to have centerline, green centerline lights that could be selectively switched in blocks of lights, and that there would be red stop bars at the end of each block. And so until 20 years ago, when this new standard came in of taxiway markings, with the letters, the Bravos, the Charlies, the Deltas. If you looked at a map of Heathrow, it gave you block numbers, block 86, block 94, and controllers could talk to pilots and say, you're clear to taxi from Terminal 2 to block 84 or whatever it was. And if that was not to the runway, it was an intermediate, there might be a stop bar there, so they didn't go beyond that. But to make this really useful, they introduced what they called the runway lighting board, the manual, and there was a person trained to listen to what the controller said to the aircraft. For example, saying you're clear from Terminal 2 to runway 27 left via taxiway da. And so the man on the desk, it was a man in those days, listened to this, and he selectively switched the chunks of green lighting to provide the complete route from where the aircraft was to where it had got to go to. So the instruction, put another way, was follow the greens and you'll finish up in the right place. And that gave the controllers some satisfaction that the pilots probably would go the right way and not use alternative ways of getting to the runway. So follow the greens, very mantrolic. You know, for anybody who's under 40 years of age, this probably looks prehistoric, but that was the way things had to be in those days. Quite a lot of human involvement, but it worked. I've stood in the tower and watched the person operating this desk had an intensive training course which lasted 6 months. So it was a specialist job in air traffic control to operate the system, but it worked. And then in the 1970s, the visual aids panel was tasked with looking at the implications of the new aircraft types that were coming along, particularly the Concorde with its limited forward downward view, and but even more so the very large aircraft which were beginning to come off the drawing board, the 747 of course leading the way there. Was this lighting going to be accurate for that? And at the same time, bearing in mind the pressure was on to go to lower and lower visibilities. In the 1940s, the lowest visibility you'd expect to taxi in was probably a visibility of 800 meters, half a mile. You could see quite a long way. But they're envisaging taxiing in very, very low visibilities below 100 meters with the pilot still controlling the aeroplane. So there was a need to look at that aspect of it, and that led fairly early on to the conclusion to do this practically, you couldn't have omnidirectional lights. You had to have high intensity, narrow beam lights with the beams specified to meet the requirement, both for straights and for curves. And a program of work went on in a number of countries, certainly in the UK, in the US as well. I think that similarly in parallel to develop high intensity green taxiway lighting. And one of the requirements was the intensity should be sufficient in the lowest visibility in which they were going to be used, that at least 3 lights would be seen beyond the cockpit combing cutoff. The pilot at all times to specify, you could see whether it was a straight line or in fact there's a curve in it. A minimum of 3 lights was shown to be necessary for that. So if we go on a little bit further in the story, that's where we set off, as it were, for the high intensity taxiway lighting. Calculations were done to say, well, in that visibility, using the famous or infamous Allard's law, you can calculate, if you know the fog density, you can calculate the intensity for the light to be seen in daylight, of course, the worst case, to enable you to see 3 lights at a certain spacing, which was also discussed and defined, and the beam spreads that were necessary, bearing in mind the aircraft might not stay exactly on the center line, which ideally it would do, but also in curves where the pilot would want to see more than just 3 lights. You'd like to see more of the curve if possible to improve his awareness of the task in hand. So beam spread and intensity. In other words, you finish up with an isocandela diagram, which is in the Annex 14 for lights for straight sections and for bends. In the background to this, it's important to understand when we talk to pilots, their experiences of the low intensity system, the shortcomings they found, and there were many that they complained about, to see what intensities they are actually looking at. And one of the reasons they were complaining so much, I remember doing a study wandering around on several international airports in the UK, measuring the outputs on these omnidirectional green lights, which, if I remember correctly, had a book value of 30 candelas in green, and finding values of 3 being not uncommon, as well as a lot of outages. It was clearly problems there, both in design and very much in maintenance. But the maintenance staff, of course, nobody had ever told them what level they were supposed to achieve. Their only yardstick was, is the filament lamp lit? If there was some light coming out of it, as far as they were concerned, it was serviceable. They seemed quite unaware, most of the maintenance people, that there's a thing called 30 candelas that was supposed to come out of this thing. As long as it was green and they could see it with the naked eye, standing 5 meters away, it was serviceable. And so when having done that, and having looked at runway centre lines whilst we were there, and finding the same thing, finding airfield centre line lighting that had been, I have to say, been approved and accepted by a flight check from our Civil Aviation Authority, probably less than 2 weeks beforehand. Instead of 5,000, I got figures well below 100 on the centre line. And that provoked the writing of a report, which was given to our CAA to say, you really ought to do something about in-service monitoring of lighting. It's not directly related to what we're trying to do now, but this is desperately important. Unless the equipment's maintained, we're wasting our time. And it took some time, but eventually contracts were let, and here we are under the aegis of tailor-made systems and MARMS. Equipment was manufactured so that the check can be done. So it had a beneficial side there. It's a bit of a side issue from actually providing the lighting, but actually very important in airfield lighting the world. We carried out some piloted simulation trials to try and identify some of the parameters, the spacings, and whether the spacings in curves should be reduced, and how easy they found the pilots to use this system we proposed with the spacing we were going to propose with the high intensity lighting. One of the big issues came out was that pilots were concerned. They wanted to have an indication in low visibilities when they could see only 3 lights that they were about to enter a curved section of taxiway, or indeed they were having to change to another taxiway. They're having to change the direction of the aircraft. And in low visibility conditions, in some cases, they would desire, in that sense, to reduce their speed even further to the low speed they were probably using to, as it were, go around the corner. So they wanted some means of being told some seconds before they got there that they probably needed to reduce the thrust a little bit more on the taxi. And we tried various techniques, different colors, color coding, but the one that was favored by the pilots, the one that worked, was to ensure that the closer spacing that you get in the curved sections of taxiway, and you'll see that in the report, that should extend for a distance of 200 feet, 60 meters, into the approach area. So the aircraft taxiing along a straight suddenly comes to a much reduced spacing on the center line, and that tells the pilot that they're about to enter a place where they will be needing to change direction of the aircraft. They'll no longer be traveling in a straight line. Well, the results of all that work are in Annex 14. Let's go to the next slide, if we may. And I just picked out, there is an illustration you'll find in Annex 14 that identifies and shows many of the things that were in detail there. For example, the top right-hand corner, you can see a stop bar showing there as part of this. So I'd say taxiway, centre line, and stop bar lighting. I've been talking about greens, but of course reds are an essential part of it for the stop bars, and unidirectional alternate green and yellow lights, again indicating a turn off a taxiway. They're the tail of lights I was discussing. Actually, you pick it up as you're going down the runway, going from bottom to top on that right-hand corner. You come to a point where suddenly you find some green lights, yellow lights, green lights, yellow lights, green. Here's the turn. Here's the rapid exit taxiway, or just a taxiway exit that they need to take. That warning there, by spacing, it's a turn, but because it's alternate yellows, it's a turn off the runway. Whereas you'll see, if you go to the left of that, you'll see the other taxiway intersection, the close space lighting there, but it's all green. So the alternate greens and yellows say this is an exit taxiway for the runway. Of course, if you're going onto the runway, you just see greens as you try and join the centre line of the runway for takeoff. And it shows the stop bars there. It shows also that still retain the blue lights. They can be quite useful, particularly defining literally where the edge of the concrete is on turns. But there's quite a lot more detail. Other applications of this, like retils, which I haven't got into today, but you find all of this in Annex 14. And with that, I think it's a time for me to stop talking and back to Robert, I think.
Tony, that was very, very helpful to kind of give us the background to how and where these standards have come from. So you're all very familiar with the final product, and even though there are, this is a dynamic environment in which we're working, but you're familiar with the product. But it's very helpful to understand how it came there and why it is what it is, because I can tell you from there's the amount of effort that goes into trying to standardize things. I've spoken to pilots and they say the most difficult thing when they fly to an airport is, if they're not familiar with it, is taxiing and navigating around the airport. And so the signs and the taxiway lighting is absolutely paramount in that. It's the most important, and the most important things they have to guide them safely and to their destination. So yes, Tony, Keith, Seward, and myself are now available to answer questions. I think we have around about just over 10 minutes left of the webinar. I've noticed whilst Tony's been working hard, Keith has been working hard too, haven't you, Keith? Keith has been Yes,
I've been trying to answer questions as we go along.
Yes.
Yes.
But I think it would benefit us all if we were to come. So you're familiar with those questions. If you could cover those now in those remaining 10 minutes, and to the extent you can, and involve the rest of the panel in those, if there are any areas which we need to discuss further. We've lost you there. I can't hear.
He's muted.
Sorry, Pago, I think you can hear me now. I was chastised by Mike West, who's on the joining us, that I had got onto him about calling AGL or airfield ground lighting and not aeronautical ground lighting. Yes, you are correct, Mike. I stand chastised myself. It is aeronautical ground lighting in formally, but traditionally around the world, it's generally being called airfield ground lighting, or AGL or AFL. AFL is used more usually in around Asia Pacific region. So that's one aspect. Then I'm trying to move these questions on now. Sorry, because I'm trying to, it's what is the basis for tilting signs and what's the best practice? that comes up, has come up quite frequently. And one of the aspects which we have discussed is that, of course, since all the original work, you know, with Tony, etc., has been done associated with guidance signs, aircraft have developed. Aircraft are developed, they've got bigger, the engine pods on the jets are in different locations, you know, so the wings hang over the taxiways, for example. So jet blast directly onto the fascia of a guidance sign, which according to ICAO standards shall be installed perpendicular to the center line of the runway or the taxiway, then can be subjected to additional jet blasts, and signs have blown away. So angling them has been one solution. The sizes of signs have also come up again, and the length of signs as what the maximum length of signs has come up more in more recent years. But angling seemed to be, you know, a logical. But I think this is, and I think Tony will agree, it is more of a thing of guidance rather than of standards. And you have to look at the layout of the airfield and the taxiway layout, and the bends, you know, the angle of the bends, etc., etc. And so maybe it's airfield specific, right?
It may well be. I think, for example, if a sign is associated with a holding position, then the location should be at the holding position. The orientation, you know, that's fixed, I think. The orientation of the sign is what you're talking about. To
Yes.
make there could be a pragmatic, sensible solution to that often by turning them away from the actual perpendicular. That
I
can
think
help.
guidance and Seward, I think in guidance that you know, the FAA are more specific, more open and more clear on their guidance as opposed to any ICAO documents.
Yeah.
Well, I think that's true. We have a design document 53-4-18, which is specifically to signs and what sign is applicable and where should it be located and so forth. So they denote a hold AC, hold advisory circular, to just the location of sign. And Carl, who's on here, he does tons of sign designs. You might have a comment on that, but we have a spec that specifically tells you where to put the sign and what signs are available for that task.
Agreed. You know, that's what I've said previously, you know, to everyone, that, you know, if there is some concern and you cannot find information or guidance in the ICAO documents, it is very, very useful to turn and look at the FAA advisory circulars, which are generally more detailed and more specific.
Yeah.
Yeah. Okay. So I think this is that, you know, this, as you say, Tony, an orientation of signs is a big thing. And one other subject that comes on is, of course, the sign shall be frangible. And it shall be frangible, so, but frangible on what? And what wind loadings? So the method of frangibility is the frangible coupling is at ground level, but that ground level means it's on a foundation of suitable composition and suitable strength to be able to withstand those wind loadings and those frangibility requirements. And that leads us on to talking about the foundations of signs and the structural strength, the composition structural strength of signs. And should a foundation be delethalized? And their answer is yes, there's clear guidance in the aerodrome design manual on the civil side that delethalization of foundations shall be implemented. And there is some guidance on that. So should an aircraft leave the pavement into the soft, as we call it, and hit a guidance sign, the guidance sign itself shall be frangible, but of course, the wheels, because of the weight of an aircraft, will dig into the soft, and therefore, as it hits the foundation, that foundation also shall be delethalized, shall be protected to save the aircraft. So it's a subject that has come up many, many times, and I certainly, and I can show you many, many photographs from many, many airports all around the world where foundations are not delethalized.
Yeah.
But regulatory wise, it does not seem to be picked up.
That's
No.
interesting point. Interesting point. And I think you're right. There's very little talk or discussion on that. Of course, we over in the States here have 3 different modes of sign. We have a sign that's supposed to withstand 100-mile-an-hour jet blast. We have a mode 2, which is to stand 200 mile an hour, and we have a mode 3, which is to stand 300 mile an hour. And those signs are certified. They're put under that loading amount when they're designed and when they're certified to make sure they can stand, for example, 300 mile an hour. But you don't put the 300 mile an hour sign all around the airport. You put it only in the locations where it's subject to possible 300 mile an hour loading. And the rest of the airport would probably have what we call the mode 2, which is a 200 mile an hour maximum. And so you have to know your airport, you know where the principal areas are of thrusts on a sign, and act accordingly. But you don't want to maximize the loading of signs all around the airport, because then you're defeating the purpose of the breakable coupling on the sign. You want it to break when an aircraft hits it, so you don't damage any more than you have to the aircraft that done the hitting.
What
Yeah.
about the foundations themselves, Stuart, on the FAA guidance on the civil side?
That's a good question, and I can't give you a good answer on that. If Carl is on here, he could give you an answer on that from the FAA standpoint. He could tell you, because he designs a lot of sign foundations, but they're specific in what you should have with regard to the loading. And Carl would be a good one to answer that question if he's here. Carl, are you there?
I think we have to initiate him to enable him, allow him to talk. I've clicked. Can you talk, Carl?
Can you hear me?
Yes.
All right.
Go on,
I was just gonna look up and see what the
We lost you.
You're back on.
Hello?
Can't hear you, Carl.
All right, let's
That
try
was a
that
good
again.
start. Right here.
No.
I'm here.
There you go.
Ah, yes, we can
The,
hear you now. Yes.
There was an engineering brief. I was gonna look it up, but you called on me and put me in front of everybody first. There is an engineering brief. I'll pull the number out and send you the chat that sets the criteria that the frangible point on those frangible couplings is required to be within 3 inches of grade. They do not address if the tire is buried in the earth and digging up dirt before it gets to that slab. They just look at the 3 inches to the frangible point. So they're, from my perspective, appear to be assuming that the tire is going to roll across the dirt, even if it digs in some, that it's still going to roll over the top of that slab. But I think they're also relying on the possibility that the tire would miss the sign, because you're looking at a tire width versus the entire aircraft, and protecting the body of the fuselage of the aircraft from damage by the sign if the tire misses it.
Okay. But I know the aerodrome in ICAO, the aerodrome design manual, like it's part 1 or part 2, then has some guidance on delethalization of the so it's not a sharp edge, you know, when it hits the whether it's concrete or whatever the material is. You know, we generally use concrete for those bases, but as someone else has mentioned, it does not have to be concrete. It
Can
has
I,
of suitable composition. Hmm?
Can I jump into this and say I think it's worth saying, changing the subject slightly, the specification in the back of the minds of the visual aids panel was that we were talking about an internally lit light box with panels on the front surface as the means of providing the sign. It doesn't have to be that way. The performance and of it in terms of, I mean, you can have a sign board with the right colours, but it has to be the right luminance levels at night to be usable. If you that but being a bit more modern, the now technologies where you can get signboards of incredible dimensions, like in sports stadia, which are daylight readable. If I was still in the business, I would want to do some research into that, replacing all our signage with that type of technology rather than the internally lit boxes. One big advantage of that was that they'd then be addressable, and that would be very advantageous in taking away one of my bête noirs, which is the runway, taxiway runway intersection, Cat 1, 2, 3 signs, whereas you taxi out, you're told you don't pass a red sign without a clearance, except today we're operating in Cat 1, so I will ignore the Cat 2, 3 red sign. That is not good human factors. You ought to be able to switch it off. And if we had the modern technology, you could switch signs off if they're not applicable, and you could put other information up today. But then going to the realms of what would be possible, but you could certainly replace them one for one with that more modern technology. You don't have to stick with light boxes with white inside with plastic panels on the front. You don't have to do it that way.
Good. Thank you, Tony. So a lot of interesting points there being raised, and I'm sure there's a lot more questions that they're coming in thick and fast here. I'll just take a couple more, and then we will close today's topic. But if you do have any more questions, put them on the chat, and then we will answer them online for you. Robert Zelensky, who we know very well, as an old colleague, former colleague of yours, Keith, I believe. You're muted. So asks, all signs power supply via the AGL and CCR, are they all powered via the AGL, by the CCRs, or are they normal low voltage, or a combination of both?
Well, it depends whether you're talking GA or you're talking categorized, instrument facilities, because there's a combination of signs that are available out on the marketplace. But generally speaking, signs in a larger airport quite often are attached to the included electrically with the taxiway edge lights, and of which then they may or may not be, of course, have intensity levels, because there's also the other aspect of controlling lights, and there is also the question of intensity levels of guidance signs, is 1, 2, 3 levels. So generally speaking, they are part of the AGL infrastructure and not as a separate LV type of power supply.
Well, in the States here, and the FAA requires that the signs always remain at the same luminous level, same light output, regardless of what circuit they're on. And if they're on a 3-step series circuit or a 5-step, the sign is so configured that that illumination output will remain the same regardless of what step the circuit is in. That's one thing they're very strict about. But what we're seeing more of over here in the States is dedicated sign circuits. And we have series circuits for just signs. We got so many signs at an airport. It aids the maintenance of them. It aids the design, is to have them on a dedicated circuit. And over here, the FAA has specified that if you put them on a series circuit, we're going to run it at 5.5 amps. 5.5 amps through that series circuit. And then it never changes. And so the sign illumination never changes. And the sign is on its own circuit.
And that's an interesting current value that has been chosen. So it would be very interesting to look at the history associated with that 5.5 amps.
Well, I don't know, Carl can comment on that, but
Yeah.
that's of a 3-step regulator. It's step 2 of a 3-step regulator, so it's
Yeah,
commonly
yes.
available. Carl, go ahead. Carl,
When the initial signage AC came out, we had the one of the advertising things that manufactured it still had incandescent lamps in it. Was the low power factor signs, because the initial signs came out and they demanded a lot of power. And then as the signage got smarter, it added electronics, but it used less electricity. By dedicating it to a 5.5 amp circuit, they were able to eliminate some of those electronics because it didn't have to go up and down with the steps. So they decided on the 5.5 amps and actually gave a little bit lower current to the incandescent lamps as well. And then since that point in time, now that they're all LEDs, the electronics are kind of a moot point, but the FAA has set some criteria that mandatory hold position signs are required to be operational, even if the runway is closed. If it's temporarily closed for construction or something, they still want those signs to operate. They still expect traffic to stop at that sign, get clearance to cross, because they don't want people getting used to blowing through that thing during construction. Then when it becomes active again in 2 months, they blow through the stops, the red line again, like you were saying.
Yep.
So they've got that requirement. And if you feed them off the runway edge light circuit, then to temporarily feed those signs alongside of, you know, a 6,000 or 10,000 foot runway gets quite expensive. So by putting them on a dedicated circuit, makes it easier to troubleshoot them. They're smaller circuits, the voltage is lower, just easier all around for the entire system. And the engineering brief I was looking for a while ago is engineering brief 79, determining runway safety area, navigate manageability and objects, and fixed by function requirements. Long title, but it's EB 79A.
Okay. Oh, thanks. Thanks, Carl.
Well, thank you, and thank you everyone for your participation today, and Tony, of course, for putting together the wonderful presentation to
My
enlighten us.
pleasure. I enjoyed it as usual.
Good. But I'd also like to thank all the panelists for their contributions today, Felicity and Damon for making it happen in the first place. But of course, most importantly, you know, without an audience, there would be no point. So I'd like to thank you all for joining us today on today's TMS Tuesday. We're having some debate about next month's exact date and timing. We will send you an email about it on that topic. As we have our annual airfield lighting, Mum's airfield lighting workshop on that day. We're wondering if we dare try and provide a live broadcast from that from our seminar. So we'll come back to you on that one. But I'd like to thank you all for now. We'll post a copy of this video by tomorrow. The video of this webinar, and answer questions and answers that we've been addressing, including any that we didn't get round to. So thank you very much, and see you all next month.